In this example, we're going to suppose that 4-year-olds in a certain country average 2.8 hours per day unsupervised, and that most of the unsupervised children live in rural areas and are considered safe. Suppose that the standard deviation is 1.24 hours and the amount of time spent alone is normally distributed. We randomly survey one 4-year-old living in a rural area, and we're interested in the amount of time the child spends per day alone per day. We want to find the probability that the child spends somewhere between 1.5 and 3.5 hours per day unsupervised. In this case, again, we're going to use our normal calculator. So here's the calculator, and this time we have to kind of pick out the information. This fact that they're 4-year-old children is not going to be data for us, but we are told that the average is 2.8 hours per day, unsupervised, and that the standard deviation we are to suppose is 1.24 hours. This time we want to find a probability that x is between 1.5 and 3.5 hours. So we're actually going to enter in two values here in our calculator. We're going to enter in 1.5 for x1, and we're going to enter in 3.5 for x2. What's our probability? Well, we're going to find our probability right here. That is 0.392577, etc. In this case, if we're rounding that to 4 decimal places, our answer is actually going to be entered 0.3926. And of course, this means that what it's saying is that, according to this survey, any randomly chosen 4-year-old that meets this description has a 39.26% chance of spending between 1.5 and 3.5 hours unsupervised and alone.